Hello everyone. On this video we will be going over different types of functions. Okay, so starting off with the polynomial function. Okay, now the different types of polynomial functions are linear polynomials, which has the form y equals ax plus b, where a and b are just real numbers. And these polynomials have a degree of 1, and we will explain what a degree is in a few minutes. Okay, so for example, you have y equals 3x plus 5 is a linear function. If you have, since y is equal to f of x, you have f of x equals 2x plus 9. That's a linear polynomial, a linear function. Or even if you have 2x plus 5y equals 16, that's a linear function because you can always solve for y. All right, let me try to focus this a little bit. There we go. Okay, so now let's look at the quadratic polynomial. And the quadratic polynomial has the form y equals ax squared plus bx plus c, where a, b, and c are real numbers. And we know that a does not equal 0. And these are 2-degree polynomials. Again, we'll explain what degrees are and how to find them in a little bit. So, for example, if you have y equals 2x squared, that's a quadratic polynomial. If you have, instead of y, let's say f of x equals 7x squared plus 5, that's quadratic. Or if you have, let's say, h of x equals 4x squared plus 7x plus 8, that's a quadratic polynomial. All right. So let's say if we're looking now at what we call cubic polynomials. So if you have your cubic polynomials, that has the form of y equals ax to the third plus bx squared plus cx plus d, where your a, b, c, and d are just real numbers. And of course, again, your a cannot equal 0. And these are polynomials of 3 degrees. All right, so for example, if you have f of x equals 7x to the third power, that's a cubic polynomial. If you have y equals 2x to the third plus 5, that's also a cubic polynomial. Or if you have g of x is equal to 4x to the third plus x squared plus 8x plus 9, that is also a cubic polynomial. All right. So this can keep going on and on and on and on and on forever till you hit some nth degree polynomial. Okay, and that would have the form of f of x is equal to, here you have your coefficients of a, b, c, and d, we're just going to make it a sub n minus 1, a sub n minus 2, a sub n minus 3, and keep on going from there. Okay, so your first coefficient is a sub n times x to the nth power plus a sub n minus 1 times x to the n minus 1 plus a sub n minus 2 times x to the n minus 2, and it keeps on going and going and going until eventually you get to your second coefficient times x squared. Then we get to your coefficient of your x term, and then you get to your constant. Okay, where in each of these cases, your a sub n minus 1, a sub n minus 2, etc., and so on, all the way to a sub 0 are all constants. And your a sub n does not equal 0. Okay, so if you notice on these two, for our 2-degree polynomial, that coefficient cannot equal 0. For our 3rd-degree polynomial, that coefficient a cannot equal 0. This is saying the same thing, that our nth degree coefficient cannot equal 0. Alright, so if you are still writing, feel free to press pause. But now we're going to move on and explain the degree. Okay, now the degree of a term is the sum of the variable exponents of that term. Alright, so what do we mean by that? Well, let's say, for example, if you have the degree of 7x squared. Well, we know that degree is 2. How do we know that? Because if you look at this term, if you have 7x squared, that exponent, variable exponent, is 2. Okay, let's look at another example. Okay, let's say if you have the degree of 4x to the 3rd times y to the 5th. Well, we know the degree of that is 8. How do we know that? It is because if you have 4x to the 3rd, y to the 5th, you're going to add those variable exponents. So we know that 3 plus 5 is 8. Okay, so let's do another example. Move that up. The degree of 2x, y, z to the 4th is 6. It has a degree of 6. How do we know that? Because when there is no exponent next to a variable, then that exponent is 1. So 2x, y, z to the 4th is the same as saying 2 times x to the 1st power times y to the 1st power times z to the 4th power. 1 plus 1 plus 4 will give you 6. Alright, so for that one, it would help to remember that x is the same as x to the first power, y is the same as y to the first power, z is the same as z to the first power. Now let me clean up that z a little bit. There we go. Alright, so let's do one more. Okay, what about the degree of 5? Okay, you think you know what the degree of 5 would be? Actually, the degree of just the number 5 or any constant by itself is 0. Okay, why is that? It's because 5 is the same as saying 5x to the power of 0. Because remember that anything raised to the power of 0 is equal to 1. So this is just like saying 5 times 1. So when you add together all of your variable exponents, you have a 0. So that's why the degree of a constant is just 0. Alright. So if you are still writing, feel free to press pause, but we're going to continue this on the next page. Alright, so what if we are looking for the degree of an entire polynomial? Okay, so in this case, the highest degree term is the degree of a polynomial. Okay, so for example, what if we wanted to find the degree of, let's say, f of x is equal to 3x squared plus 2xy plus 3xy to the third plus 7. Alright, so what we do is we find the degree of each individual term. Okay, so first we're going to rewrite, and all the ones that's missing an exponent next to the variable, we're going to put one there. Okay, so we have f of x is equal to 3x squared plus 2xy, so that's 2 times x to the first and y to the first. 2x to the first power and y to the first power plus 3x to the first y to the third, 3x to the first y to the third plus 7. You can put 7x to the 0 power if you want to. You don't really have to. Okay, so we find the degree of each one of those terms. Okay. So 3x squared has a degree of 2. 2 times x to the first, y to the first. You add those together. This has a degree also of 2. Okay, so if you add these two together, 1 plus 3, you see that this has a degree of 4. And any constant just has a degree of 0. Okay, so out of all of those terms, this is the largest degree, or the highest degree. Okay, so whatever your highest degree is, that's going to be the degree of the entire thing. Okay, so in other words, f of x equals 3x squared plus 2xy plus 3xy to the third plus 7 has a highest degree term, and clean up that g. Move that up some. of 4. So the entire polynomial has a degree of 4. So the entire polynomial has a degree of 4. See? So that's how we would find the degree of either an individual term or an entire polynomial. Alright. So if you are still writing, feel free to press pause. But we're going to go ahead and look at the remaining functions. Okay, so we have our power functions. And your power functions have the form f of x equals k times x to the power of p, where k and p are just real numbers, so that's your coefficient and that's your power. Okay, so we know that k and p are real numbers. There we go. All right, so for example, if you have f of x equals x to the third power, that's a power function. Or if you have f of x equals 3x to the fifth power, that's a power function. Okay, even if you have 3x to the square root of 5 power, that will be a power function. All right, so if you have f of x equals 2 over x to the 7th power, if you just rewrite it as 2 times x to the negative 7 power, that's a power function. Okay. Next would be the root function, which is just like the name says, you would have an nth root. F of x equals the nth root of some x. Okay. Now you want to remember that the nth root of x is equal to x to the 1 over nth power. So, for example, f of x equals square root of x is a root function. Or f of x equals the 5th root of x is a root function. Or f of x equals the 8th root of x is a root function also. Okay, so those are just a couple of examples of your root function. Okay, so you have your reciprocal function. And your reciprocal function will have the form of f of x equals 1 over x to the nth power. Okay. So as you can see, your reciprocal function is also a power function. So the functions can belong to more than one group. Okay, so for example, if you have f of x equals 1 over x to the 5th power, or f of x equals 1 over x squared. All right. So let's look at the next one, which is our exponential function. Where we have f of x equals b to the power of x. Okay, we know that b does not equal 0. All right, so for example, if you have f of x equals 3 to the power of x, that's an exponential function. Or f of x is equal to negative 4 to the power of x. Let me clean that up a little bit. Okay, those are both exponential functions. Alright, so now let's look up to our next one, which is our logarithmic function. Logarithmic function. Okay, and that would have the form of f of x equals log base b of x. Okay, so for example, if we have y equals log base 2 of 5, or f of x equals log 100. Okay, those are both logarithmic functions. All right. So what if we move on to our next one, which is our trigonometric functions. Trigonometric functions. Okay, and those are just all of your trig identities. Okay, so for example, if you have f of x equals cosine of x, or f of x equals secant squared of x minus sine squared of x. Okay, those are both trigonometric functions. Alright, so we have a couple more, but we're running out of room on this page. I'll just continue. Okay, so if you are still writing, feel free to press pause, but we're going to go ahead and finish this up on the next page. Have to do a little back page. There we go. Okay, so now we're going to look at the rational functions. Okay, and with your rational functions, is basically just a quotient where your numerator and denominator can both be polynomials. Okay, so that's your function where your numerator and your denominator can be polynomials. Okay, where P and Q are polynomials. Alright, so for example, you have f of x is equal to x plus 1 over x minus 2. That's a rational function. Or f of x is equal to x squared plus 2x plus 4 over 3x. That's a rational function. Even if you have, let's say, g of x is equal to 1 over x squared plus 2x plus 1. That is a rational function because 1 is a polynomial. Okay? It's a single term polynomial or monomial when it's just one term, but it is a polynomial. Alright, and last but not least, we're going to look at the algebraic function. Algebraic functions. Okay, so this is last because you kind of use a little bit of everything. So you use algebraic operations. And that just means our add, subtract, multiply, and divide. And we also add in our polynomial roots. Alright, now quick note about algebraic functions. Rational functions are automatically algebraic functions. Okay, so all of your rational functions up here, they will fall under the category of a rational function, but also the category of an algebraic function. So everything up here would also be an algebraic function. Okay, so let's say, for example, if you have f of x equals the square root of x to the third plus x squared plus 1. Okay, this is a polynomial root. This isn't just a root. Now, if you just had square root of x to the third, that would be a power function. I mean, a root function. But because you have the root of a polynomial, it's an algebraic function. Or even if you have g of x is equal to x to the fourth minus 16x squared over x minus square root of x plus x minus 2 times the cube root of x plus 1. This entire thing is an algebraic function. Alright, so that's it for our explanation on the types of functions. Hopefully this made sense, and I will see you on the next video.